Events involving and conditional probability, section 11.7. Independent events. Two events are independent events if the occurrence of either of them has no effect on the probability of the other. For example, tossing a coin two different times. Now, do not confuse independent events and mutually exclusive events. Mutually exclusive events cannot occur at the same time, but independent events occur at different times, although they have no effect on each other. And probabilities with independent events. A die is rolled, then a coin is tossed. Find the probability of rolling a number greater than 3 and then the coin landing on heads. First, we're going to list our sample space. So notice we're looking at all numbers that are greater than, when we're rolling a die, let me say that, a number greater than 3. And then the coin landing on head, the coin landing on heads. So you notice we have each our sample space, and let's proceed. So greater than 3 and landing on head. So that's what we want to look for. This is our sample space. We have 6 sides to a die. We have 2 sides to a coin. So this is our sample space. So we're going to pull the information from out of our sample space. So what we have here is how many from our sample space, how many do we have as far as the die being greater than 3 and landing on head? How many times does that occur? Well, we have here 3 times. So because we're going to be looking at 4H, 5H, and 6H, and H representing the head, then how many of the total outcome? We have 12. So that gives us 1/4. Continuing, if A and B are independent events, then we would say P of A times P of B. We're going to multiply those events together. Here we go. A die is rolled, then a coin is tossed. Find the probability of rolling a number greater than 3 and then the coin landing on heads. So we have the word and there. So we're going to multiply. We have P of greater than 3 and H. So equals 2. This is our formula. P of greater than 3 times P of H. So we have 3/6. So that now we say greater than 3, think of the die. We have 6 sides. So our goal, we're looking for numbers that are greater than 3. That's 4, 5, 6. So, and then the total outcome is 6. And then our coin, we have 2 sides to a coin. What's the probability of us landing on a head, which is 1/2, which is 1, and then we have 1/2. So let's multiply. And I noticed that in this particular PowerPoint that 3/6 was reduced to 1/2. And then we have 1/2 times 1/2, which is 1/4. Next one, if the probability that South Florida will be hit by a hurricane in any single year is 5/17, 5/19, here we go. What is the probability that South Florida will be hit by a hurricane in 4 consecutive years? So as we set up our equation, we're looking at P of hurricane times hurricane times hurricane times hurricane. we're going to multiply the word and. So we're multiplying 5 over 19 4 times. And we have 625 over 130,312, which as a decimal is 0.0047. Next example, if the probability that South Florida will be hit by a hurricane in any single year is 5 over 19. We have that again. Here's our question. What is the probability that South Florida will not be hit by a hurricane in the next 4 years? So when we're saying not, the formula is 1 minus. Okay, we're looking at that event. So we have P of no hurricanes, which is 1 minus P of hurricanes, and we have 1 minus 5 over 19. And 1 in fraction form is equivalency will be 19 over 19. And this is where we have 19 over 19 minus 5 over 19, which yields 14 over 19. Okay, so we have that information. So now we're going to take the information about no hurricanes and we're going to multiply that times each event 4 over 19 4 times. And we get a value of 0.2948. Same starter here for this question. Now it says, what is the probability that South Florida will be hit by a hurricane at least once in the next 4 years? We have here, because P of not E is equal to, that means the event, 1 minus P, P of E. So P of no hurricanes in 4 years. We're going to write this as 1 minus P of at least 1 hurricane in 4 years. And remember from logic, the negation of at least is no. So it says if you rearrange the equation, P of at least 1 hurricane in 4 years. So we're saying 1 minus the previous slide, 0.2947, which is equal to 0.7052. Last example, I believe. The probability of an event happening at least once. This is the formula that we're using. P of event happening at least once is equal to 1 minus P of event doesn't happen. Okay, so I'm wrong. We have some more slides here. Dependent events. 2 events are dependent events if the occurrence of one of them has an effect on the probability of the other. If A and B are dependent events, then P of A and B is equal to, and this is the formula, P of A times P of B, given that A has occurred. So A has to occur here. We have an example. You are dealt 2 cards from a standard 52 card deck. Find the probability of getting 2 aces. So we're going to set up our equation. P of ace times P of ace, given that ace was dealt the first time. So we have 4 aces in a 52 card deck, so 4 out of 52. And given that ace was dealt the first time, the next event, okay, We're one less a card, ace card, so 3 over, and we're one less a deck of cards, so that's where we have 51. So 4 over 52 times 3 over 51 was reduced to 1 over 13 times 1 over 17, and we have 1 over 221. Let's go back because I went kind of quickly on there. Next vocabulary, conditional probability. The conditional probability of B, given A, written P of B divided by A, is the probability that event B occurs computed on the assumption that event A occurs. So here's our formula for conditional probability. P of B divided by A. So you're saying the number of outcomes common to B and A all over the number of outcomes in A. You're dealt one card from a 52 card deck. Find the probability that you will be dealt a heart, given that the card is red. So we're looking at the number of hearts that are red all over the number of red cards. Okay, so we have here, there are 26 red cards. How many hearts? There are 13, so we have 13 out of 26, which reduces to 1/2. And there we go.